Hey everyone, in this lesson we're going to learn about the characteristics of higher order polynomials. So this is our first lesson in Unit 6. So let's start off with talking about the types of polynomial functions that we have, and we've already seen some of these. So if you have a constant function, your function is said to have a degree of 0 because there's no x involved in it. So technically your x is to the 0 power. Anything to the 0 power is 1. So the x part goes away. So the equation for a constant function is going to look like y equals some number, we'll call it c for constant. And the picture looks like a horizontal line. Think about Hoy-Vux, horizontal line, y equals a number. Okay, the next type of function we definitely have talked about, a linear function. That has a degree of 1. The equation is y equals x, right? X to the first is what that is. And the picture for that particular function is going to be a diagonal line. Okay, think about your slope. All right, our last unit that we just finished up was quadratic unit. All right, degree is 2 because it's y equals x squared. And of course, that takes a U shape known as a parabola. All right, at the beginning of the year, we did talk about cubics just a tiny bit, just mainly to get what their shape was and what the equation was. So it has a degree of 3. The equation y equals x cubed. Okay, it looks kind of like this. We say it's like the disco dance. Okay, all right, and then quartic, you could probably guess, is going to have a degree of 4. It's going to be y equals x to the 4th. Now, with your quartics, technically you could potentially have a parabola, again as your picture, or you could have like a W shape like this. It's all dependent on the particular function that you're talking about. So let's talk about end behavior. So that's one of the characteristics that we did talk about at the beginning of the year, but it's been a little while. So end behavior basically tells you what are your arrows doing on each side. All right, and when we're dealing with higher order polynomials, we can look at two things to help us determine our end behavior without actually having to graph it in Desmos or a graphing calculator. All right, and those two things are the leading coefficient, so the number in front of your x, that's to the highest degree, and your degree, and again, degree just means the exponent, the highest exponent in your problem. So my leading coefficient here, all right, is going to describe the right end behavior. So it's going to tell you what your function is doing on the right. Okay. If our leading coefficient is positive, that's going to mean that our right end of our graph is going to be going up. Okay, it's going to the right, it's going up if our leading coefficient is positive. So what does that look like? X goes to infinity, f of x goes to infinity. You can also replace that with y as well. All right, if our leading coefficient is negative, well, the opposite is going to happen. So on the right, we're going to be going down, okay? But because we're going to the right, x is still going to positive infinity, but f of x is now going to negative infinity. All right, degree describes what's happening on the left, okay? Now, if your degree is even, it's going to open the same as the right. Think about it. You want to kind of keep things even. Okay, you're going to be doing the same thing to both sides, if you will. All right. If the degree is odd, think opposite. So it's going to be the opposite of the right. Okay. And here's a little chart that you can use to kind of help remember this. Okay. So if your leading coefficient is positive and your degree is even, we like to think of this as up, up. So that means as x goes to the right, x goes to infinity, f of x also goes to infinity. Sorry, things moved on me. Okay. As x goes to the left, okay, x goes to negative infinity. All right, f of x is still going up, okay, because of that even degree. All right. If we have a negative leading coefficient, but we're still even, okay, negative, we know that means going down on the right, but we're even, so it does the same on the left. So this one's a down, down. So x is still going to positive infinity. F of x is going to negative infinity. And as x goes to negative infinity, f of x is also going to negative infinity. All right, if we have a leading coefficient that's even, okay, or sorry, positive, and our degree is odd, okay, we know we're going to be going to positive infinity on the right, okay, but because we're doing odd, think opposite, we're going to be going to negative infinity on the left. Okay, so think about your odd functions like x cubed makes sense, disco dance, right? Okay, so x goes to negative infinity, f of x is also going to negative infinity. Okay, and then for our last case, we have a negative leading coefficient and an odd degree. So that means on the right, we're going to be going down, but on the left, we're going to be doing the opposite. We're going to be going up. So as x goes to negative infinity, not negative infinity, I meant to do positive infinity, I apologize. Positive infinity, f of x goes to negative infinity. And as x goes to negative infinity, f of x is actually going up to positive infinity. Oy, oy, oy. Everything's moving on me. There we go. Okay. We have some other characteristics that we need to be aware of. Okay, so remember, n represents the degree of your polynomial. So your extrema, a polynomial can have at most n minus 1 extrema. Remember, extremas are maximums and minimums, mountains and valleys. Okay. X-intercepts. A polynomial can have at most n x-intercepts. So whatever your degree is, that tells you the amount of x-intercepts you could have. Remember, x-intercepts are for real numbers only. So that's why it can be less, because we can have imaginary solutions, and you're not going to see those on a graph. All right, your y-intercept is always going to be the constant value, because you put in 0 for x to find your y-intercept. Everything goes away except for the constants. All right, and your zeros or solutions, a polynomial always has exactly n zeros or solutions. Now, not all of them are going to be real, so that's why it's different for the x-intercept piece. So let's look at some examples. So example number 1, my degree for this one, if you look across, oh, your degree is 4. That's your highest exponent. Your leading coefficient, if you were to rewrite this so that it was in standard form, which would be a good idea, so negative 4 or negative x to the 4th minus 2x cubed plus 2x squared plus 4x. I'm sorry that everything keeps moving on me today. All right, my leading coefficient is actually negative 1. So I have a degree of 4, but my leading coefficient is negative. So if we have an even degree, but we have a negative leading coefficient. Okay, what does that mean? It means on the right, we're going to be going down, and we're going to also be doing the same on the left. Okay, so for my end behavior, x goes to infinity, but f of x is going to negative infinity, and x goes to negative infinity, f of x is also going to negative infinity. Ah, what am I doing today? Sorry about that. Okay. So for the number of possible extrema, remember that's just n minus 1, so 4 minus 1 is 3. My y-intercept is going to be my constant. Well, if I plug in 0 for all these x's, everything goes away and there's no constant. So my y-intercept is going to occur at 0. So remember your x is also 0, so it's actually at 0, 0. And my number of possible zeros is just my degree, which is 4. All right, for the second problem, my degree is 3. My leading coefficient is 1. So an odd degree, but a positive leading coefficient. So that means we're going to be going up on the right. So x goes to infinity, so does f of x. And we're going to be doing the opposite on the left. So as x goes to negative infinity, f of x is going to negative infinity. Okay, my number of possible extrema, 3 minus 1 is 2. My y-intercept is going to be at when y is 4, 0, 4. My number of possible zeros is going to be my degree, 3. All right, the last problem, we're going to take it a tiny step further, and we're going to see if we can kind of sketch a graph of this. All right, so my degree is 3. All right, that's odd, so I know it's going to be doing opposite things. All right, my leading coefficient is 1. My number of possible extrema is going to be 2. My end behavior, because my leading coefficient is positive, on the right, we're going to be going to positive infinity. And we're going to do the opposite on the left. Okay, my y-intercept, if I plug in 0, I get out negative 8. Okay, number of possible zeros is 2, and minus, or sorry, not, sorry about that, not 2, it's 3, my bad. All right, and now we want to figure out what are those zeros, okay? So some of this I can actually already graph, like the y-intercept being negative 8, if we counted by 2's, so negative 2, negative 4, negative 6, negative 8. So my y-intercept is right there. Okay, now x cubed minus 8 set it equal to 0, and we're going to factor. We're going to solve by factoring. This is a difference of cubes, so remember your pattern from the beginning of our factoring unit. So x times x times x gives me x cubed, so that's my a value. 2 times 2 times 2 gets me 8, that's my b value. All right, then it's a squared, so x squared. A times b, 2x. B squared, 4. Okay, and then same, opposite, always positive. Okay, now we're going to set these factors equal to 0. Okay. So this one's really easy, right? X equals 2. That's nice. X equals 2. Put a point there. Okay, and then this one, this won't factor for you, okay? But we have learned that we have some other options, right? We could try to complete the square. We could try to use the quadratic formula. Probably quadratic formula is going to be our best bet. So let's find our discriminant first. So b squared minus 4 times a times c. All right, so 4 minus 16, that's going to get me negative 12. What does that mean? It means that I have 2 imaginary solutions. Okay, so that would make up my 3 zeros, or my three solutions, right? We have 1 real and 2 imaginary. Okay, so because of that fact, we're not going to be able to graph any more points unless we just started plugging in stuff. So just as a rough sketch, we know on the right, we're going to end up going up because of the positive leading coefficient. Okay, we're going to have some sort of curve here, okay, but it's just not going to hit that x-axis, and then it's going to be going down on the left. So there's kind of a rough sketch, and you could obviously graph it on Desmos and see how you did. So, and that's higher order polynomial characteristics.